Okay, so you guys have done transformations every single chapter. Every single chapter, I think, besides one. So this should be something that is not new, so hopefully we can fly by. If you were to open your interactive notebook, remember that bright green sheet at the very beginning? That's transformations. So we're going to go back to it because every function can be transformed in some way. Okay, so flip open your pink packet. We know that x squared looks like a u. I want you just to be able to identify that x squared is going to be a u. So that vertex point is right here at 0, 1.
Isn't that a y though? Y.
No, a y would have like a stick at the bottom. Yeah. Okay, so relax. Okay, so that initial point here is at 0. That was our vertex. So I'm just going to go ahead and put that in, 0, 1, right in the middle. Wherever your starting point or your vertex should go in the middle. Again, you can find all of these points on your graphing calculator, but I'm going to try to get you guys to try to start using your head a little bit more in these situations. Hi.
Like, it's not like not linear.
It's quadratic.
That's quadratic and x raised cubic.
Yep. Okay, so quadratic. So what is 1 squared? Because if I'm going to put in 1 into x, I'm going to go the other way, I'm sorry. If I'm going to put 1 into x, what would you get? 1, yeah, because 1 squared is 1. So here we go, 1, 1. If I put in 2 here, right here, what's 2 squared? 4.
Oh.
So I'm going to put 2 up 1, 2, 3, 4. Okay, there's actually a pattern for quadratics that I think might be very useful for you. I'm going to try to teach it to you this year. So whenever you're doing squares, quadratics, you're going to go right 1, up 1, right 2, up 4. Okay, that's the pattern. But then you go the opposite. I go left 1, up 1, left 2, 1, 2, up 1, 2, 3, 4. Because remember, this is what it's going to look like here. What happened?
That other one is.
Oh, I messed that up. Sorry. Here we go. Better?
Sorry. Never mind.
1, 2, up 1, 2, 3, 4. What do you mean? Sorry, I want you to explain it.
I can't. Well, it looks like it's over one.
So this is 1, and that's 2. That's 1, and that's 2. Okay. All right, so then, again, I went negative 1, and I went up 1, and I went negative 2, and I went up 4. Okay, they're symmetric. Remember that they fold. Hopefully you start to get used to what it looks like. If you don't, you can go to your graphing calculator and type it in and get these values. That's fine. I'm just trying to get you used to not using calculator all the time. Some of you are really good at patterns. So this might be helpful for you. Right 1, up 1. Right 2, up 4. Then you just go the opposite direction. Okay, now let's talk about cubic. Again, we did this in chapter 5. I'm always going to start at this initial point, 0, 1. Always. Sorry. Oh, I'm sorry, 0, 0. Thanks.
You said 0, 1. It might be 0, 0.
You're correct. See? That's why I have you guys.
Yep, we're good.
That's how I have you guys. I need you guys just as much. Yeah, my bad.
0, 1.
You just tell me earlier so I don't confuse anyone. Just tell me earlier. Okay. So perfect. 0, 0. I apologize for that confusion. All right. Now let's talk about cubic. If I go right 1, how much must I go up if it's cubed?
3,
1 cubed.
2,
What's 1 times 1 times 1?
1.
1.
You say false?
So it's kind of cool how that pattern doesn't change. However, if I go right 2, which is going right 2 here, how much would I go up? What's 2 times 2 times 2?
4, 8.
Very good. 4, 8. See, you worked it out. 1, 2, 3, 4, 5, 6, 7, 8. Now, for cubic, it's the same thing, but all of the signs change. So, yes.
It would make it an odd function.
It would just go the opposite way.
It is an odd function. You're right. So now I would go the opposite way. I would go down, left, and then down. Left, 2, down, 1, 2, 3, 4, 5, 6, 7, 8. Okay, that's what a cubic looks like. Remember this little snake-like thing that looked like this way back when?
Oh.
So I'm going to write out the other part of the pattern. I went left, 1, down, 1, left, 2, down, 8. Okay? Now, again, you only really, if you like patterns, memorize half of it. You should be able to draw the other pieces because they're symmetric in some way. This one's just symmetric about the origin. So I went left 1, and I went down 1, and I went left 2, down 8. Again, you could graph all of this in your graphing calculator and you get all these points. I'm just trying to get you to do stuff without your calculator and stop relying on it. Quadratic looks like a U. Cubic looks like an Egyptian. Remember like the little Egyptian like characters that you always see? Remember odd functions always go opposite directions from chapter 5. Odd opposite, odd opposite, odd opposite. And then even functions go the same direction. Okay? From way back when.
Yeah, because like the square wasn't like that.
Yeah.
Like this or like this.
Yeah. So any even function's going to go the same direction, either up or down.
Okay.
You could even have like, as long as it was going the same direction, it's fine. Good. All right. So let's talk about these now. Graph the following and describe any transformations. Now look, here's the cool part about memorizing the pattern if you like patterns, because it doesn't change. As long as you start at the point of inflection or that vertex point. We're squared here. So am I going to be the same direction or the opposite directions? The same, which is awesome. But now let's talk about each piece. I'm going to talk about each one here. This 3 is different, bless you, and this 4 is different, bless you.
Bless you.
Let's talk about the blue piece. You guys should be good at this. Am I going left or right 3?
Right.
You're going right 3. So that's going to be my new vertex point. And then in green, what am I doing? Going up or down? Down 4. So that's my new vertex point. So let's just graph that out. So 3, 1, 2, 3, down 1, 2, 3, 4, right here. Guess what is awesome about this? The pattern doesn't change, which makes this awesome. If you don't memorize the pattern, you're going to have to just plug in the answers or go in your calculator and get them. Because we're still, guess what, going to go right 1, up 1, right 2, up 4. But you're starting at the point in the middle, the vertex. So right 1, 2, up 1, 2, 3, 4. And guess what? It mirrors. When you're talking about quadratics, it's always going to mirror
Where are all these dots coming from?
the pattern. Good question. So I'll redo that so that you kind of get a reminder here. So remember earlier we kind of talked about how a quadratic goes right 1, up 1, right 2, up 4. That pattern will always stay the same as long as you start the point that you start from. So as long as you start from that vertex point here, which we found was 3, negative 4 based off of your transformation. The 3 and the 4 is where we start here. Yeah, very good. So then these just kind of reflect over because it's a quadratic. Again,
How did you see the 3 and the negative 4 and get the other point and the other point?
these two?
Yeah.
That's what I just talked about with Tommy. So that pattern, here we go, let's do it again. I went, zoom in. I went right 1, up 1, because that's the pattern. Right 1, up 1. We talked about it a little bit earlier. Then we went right 2, 1, 2, and we went up 4. 1, 2, 3, 4. So as long as you're starting with the vertex, it will never change. Again, a lot of you are like, what the heck? I say a lot of you just plug in my head. That's fine. I'm showing you another way. If you want to be a mathematician, you want to actually know how to do things without always relying on technology, this is how you do it. If you're someone that does not care, put in your calculator and get it. I'm just trying to show you a way to do it without using your graphing calculator. So if you see here, we have half the parabola, right? Because we're squared. So we need the other half. We need the other half, which just mirrors over. It literally just mirrors to the other side. There you go. I don't care if you have these tables. If you do not use the calculator, you don't have to fill this in. If you use the calculator, you need to fill it in. So I know that where it's coming from.
Wait, for the after second, did you go all 1 over 4, all 1 up 4, or was it all 2 up 4?
I went right 1, 2, and I went up 1, 2, 3, 4.
Oh, okay.
Okay.
So it's not, so when you go all one to up one. You don't go from all two over from that second point.
You always start from the point that the vertex. So maybe like highlight or star this piece. You always start, so if you're using the pattern, again, if you're someone that does not care about patterns, then don't worry about it. Start putting in your calculator. If that's someone that you want to do, you always start at your vertex, which is this point right here. That's why I went right 1, up 1 from there. I went right 1, up 1 from there. I went right 2 and up 4 from there. I'm telling you, it's really not a hard pattern to memorize. Right 1, up 1, right 2, up 4. You memorize that, you don't have to do anything. You don't have to plug it in, nothing. It's pretty straightforward. Nothing. All right, let's talk about this one though. Now we're in cubic. So that means that we're going opposite directions, which is kind of like the one right above it. So, but before we do that, you have to identify your transformations to see where are you starting. Where is my point of inflection here? So what does this 2 mean?
-2.
Which means I'm going left 2. So write that down. So that's going to be where I start. That's why I'm going to start at that left 2, which is technically negative. And then what does this +1 mean? Up 1. So my point of inflection is left 2 and up 1. That's that point. Like if you want to star it or highlight that point, it's super important. Or if you have a different color pen, maybe like make that like a highlighted feature. Because that is where you're starting. And now you can use the pattern. Remember, you're talking about cubics. So my pattern was, I'm going to keep writing it out. Maybe you should write out every time too, just until you memorize it. It was right 1, up 1. Right 2, up 8. There's only 2 patterns you really have to memorize. That's it. Because think about it. 2 cubed is 8. 2 times 2 times 2. That's where we're getting that from. So here we go. Right 1, up 1. That's the first point. Right 2, 1, 2, up 1, 2, 3, 4, 5, 6, 7, a little bit up here somewhere. Now, again, if you understand the shape of a cubic, it's just the opposite sides. Okay, so now I'm going to be going left 1, down 1, left 2, down 1, 2, 3, 4, 5, 6, 7, 8. As long as you understand that cubic is going to be going opposite directions, you'll be able just to put those points on the paper. You're just doing the opposite. So instead of going right 2, I'm going to go left 2. Instead of going up 8, I'm going to go down 8. So I'm just going to write that out for you. I'm going to go left 1, down 1, left 2, down 8. Just until you get used to the pattern. Again, I'm going to say it one more time. You do not have to do it this way. You could just go on your graphing calculator and get the point. Yep.
Where'd you get the 8? I thought it was 4.
You're right. And here's the difference. Good question. I'm going to come up here. This is a squared, and that's a cube. So 2 cubed is 2 times 2, which is 4, times 2 one more time is 8. But it's good to understand where this is coming from. You should be asking these questions. I get these questions all the time. It's not bad questions at all. Now, again, if you choose to do the pattern, which is this, you don't have to do the table. If you want to just use your graphing calculator or use Desmos when you're at home, then just get the table. Write that in. I don't really care. I would recommend writing this pattern out every time until you have it memorized if you're going to use a pattern. So many people like the pattern because it's pretty straightforward. You don't have to get out your graphic calculator. All right. Now, here's where it gets a little tricky with the pattern, but not too much. Same kind of situation. You always have to identify, am I going to be doing a square or a cube? I'm going to be doing the even here. So I should be going the same direction. They're both going to be pointing up. So, what does this negative out in front mean?
It is going to go down.
Yeah, which means reflect. What does this 2 mean? Who remembers that? It was either stretch or compress. Stretch. By 2. So really what you're doing is you're multiplying all of the values by -2. Not the x values, the y values. Okay, so this is kind of where it gets a little tricky if you forget that. Technically, I'm going to put like a little star here. You're going to multiply the y values by -2. Again, feel free to put in your graphing calculator. If you're someone that's like, I don't want to do that much work, just put in your graphing calculator. I'm telling you, I'd find it faster than you would trying to type in the calculator. Okay, so the pattern O is right 1, up 1. Okay? Right 2, up 4. With your transformations, you put a little arrow here. I'm still going to go right 1 and right 2. However, I told you that we're going to have to multiply these y values by -2 because so we're going to be going down what? 2, yeah. And then what about the next one?
Down 8.
Down 8 because you're multiplying by 2. Okay, so I'm going to put like a little star here. I multiplied by a -2, and that's how I got these answers. I'm telling you, it seems really weird and like confusing, but it actually is really easy once you get used to it. You're not gonna know how to do it right away. I'm not saying that. It's gonna take some practice. But now that I've had people doing it for like almost a whole semester in my other class, they're like rocket scientists when they're graphing these things now. Okay, so again, I'm starting at 0, 0s right now because I didn't move left or right anything. And like I said, this is my new pattern. I'm going to go right 1, down 2, right 2, down 1, 2, 3, 4, 5, 6, 7, 8 down here. And then it just reflects over. And this is my new graph. And if you were to graph that in your calculator, you would see that's correct. It makes sense because like I was told, you guys told me a negative out in front means I'm going down, and I am in this situation. Okay, again, all of this stuff can be done in the calculator. I'm not saying that it's required for you to memorize this pattern. I'm just showing you a different way for those that are really interested in actually understanding mathematically why things are the way they are. Okay, I'm going to cross this one out. I don't like it. On my shoulder.
I think we should skip all these.
I think that you should just flip the page. Okay, same exact thing. Same exact thing, but now we're doing the inverse. We talked about that the squared function, the inverse is a square root. We already talked about that yesterday. So guess what? Remember that pattern that you memorized. You don't have to memorize anything else, but what happens to all the values when we're talking about the inverse? They swap. Okay, so that's the cool part about patterns, that you can memorize one pattern, and as long as you understand what's going on, I'm understanding that the square root is the inverse of a squared, so I know all the values switch. So the pattern stays the same, but they switch. What do I mean by that? So originally we went right 1, up 1. If they switch, we're still going right 1, up 1 because the ones didn't change. So we're still going right 1, up 1. The original pattern was right 2, up 4. They square it. What is it going to be now? Right 4 and up. Yeah, very good. Here's why. What's the square root of, this supposed to be a 2. That is a 2. What's the square root of 4?
2.
Square root
2.
is 2. Okay, the square root of 4 is 2. So that pattern makes sense. Do you see how you memorized one pattern, which was this one? Knowing it's the inverse, it just switched. Okay, that's the cool part about it. If you're a pattern person, I would recommend for the homework or for even the test, trying to do it, verifying with your calculator. Because if you type this in the calculator and you don't get the graph that you created, then something went wrong, and then fix it. But always try to do it at first alone. So here we go. I'm always going to start at 0, 0. And I'm going to go right 1, up 1. What did I do?
I was thinking garbage at me.
Stop thinking garbage. Okay, right 4, 1, 2, 3, 4, and up 1, 2. Hey, didn't this graph look just like this? Just drop it. Just drop it. Perfect. Awesome. He'll pick it up with his hands later. Okay. It looks exactly what we were just doing yesterday. That looks like the square root function, right? We did that yesterday. It looks like it. Again, you don't have to do this unless you want to. It depends on if you want the pattern or not. Okay, same thing here. So it's kind of go off of what we already know. Our first pattern was right 1 and up 1. If I switch it, does the numbers change at all? No. So right 1, up 1 still remains. Originally, I went right 2, up 8. So now what's the inverse? Yeah. And up, yeah. Here's why. The cube root of 8 is 2. It makes sense. And that's it. That's all you need. So I always start at 0, 0. In this situation, unless we're transforming. I write 1, up 1. Right, Tommy? You're looking it up?
Yeah.
Okay. Right 8. 1, 2, 3, 4, 5, 6, 7, 8, and up 1, 2. Again, you can always verify on your calculator. We always do the opposite for our odd function. So I'm going to go left 1, down 1, left 8, down 2. And here it's going to make it look really weird. This one you have not seen yet. It looks like this. Think about that. The cubic in our first page looked like this. Well, it literally just flips like that. Yeah, because all the x and y's changed, so it just rotated the other direction. And it kind of looks like the one we just drew on the left side. It's just missing that negative piece right here. And why don't we have that? It's because we can't have negatives under the radical. It's crazy. Yeah, all right, cool. So, 8a. Same thing, the transformations are not changing. Act like this square root is technically a parenthesis. Like if I put like parentheses right here, you tell me what would be going on with the 5.
Left 5.
Yeah, because you're doing the same thing. Left 5 and down 2. Okay, so nothing is changing with the transformations. It's the best part is the mathematicians did not want to confuse you, and it means the same exact thing. But now you're just in a square root. So now that's where our new point's going to be. So I'm going to go left 5, 1, 2, 3, 4, 5, and I'm going to go down 1, 2. That's important. If you were to highlight something or like star something, like that's that point of inflection or my starting point. Let's go to our pattern because we're square root now. My square root pattern was right 1, up 1. So let me draw that. Right 1, up 1. Then it was right 4, up 2. So 1, 2, 3, 4, up 1, 2. And it looks something like that. I'm telling you, you're going to be geniuses by the end of the semester. I know this is difficult math, but I think you're going to be fine. You're not going to know it right away, but you'll be fine. I think you'll be okay. Same thing here. I want to go to this one right here for 8C here. What does this negative 2 mean? Right. Is a cube root. What is this one right here? Yep, down 3. You need to identify your transformation because that's where you start your pattern. Now, something to highlight. I should have had you guys have highlighters today. It's okay. But you need to know where you're at. I'm cubic, so that means I should be having arrows going both directions. If I'm in the square root here, that means I'm only going one direction. That's why that one's only pointing one direction. One direction. Okay. So, I'm going to go right 2, 1, 2, and I'm going to go down 3, 1, 2, 3. That's the important point there. That's that point of inflection. Where the point of inflection, you're probably like, what the heck are you talking about? That's where it changes direction. You notice in like the little snaky, where it starts to change direction is where that point of inflection is. So our pattern was right 1, up 1. So right 1, up 1. And then it was right 8, up 2. Pattern? It's a table of values. If you were to put it in your calculator, you would see that this was, if I plug in values here, the cube root of 1 is 1. So that's right 1, up 1. What's the cube root of 8?
Yeah, but like where does like 8 come from? Like how do you know?
I know that 8's a perfect cube. Because if you do the cube root of 5, it'd be like a decimal. And I don't really want to work with that. I don't think you guys would want to work with decimals either. And the cube root of 8 is going to be 2. Yeah. Not sign up. Okay, that's where it's coming from. I understand what you mean by that now. Yeah, if I did the cube root of 7, you would get some weird, funky answer, and you would now want to be playing with that. All right, so now let's go back here. So it's going to be somewhere up here. Again, it's going to be off the map, but it's okay. So now we do the opposite. I'm going to go left 1, down 1, left 8. 1, 2, 3, 4, 5, 6, 7, 8, and down 1, 2. Remember, it kind of looks like a little snake. Just connect the dots. I always recommend when you're drawing these graphs that you draw it correctly. If you have the dots or the points on there, if you draw left to right, it'll be drawn correctly. Because here's what I see a lot of people do. They'll be like, oh, okay, I'm going to go like, I don't know, like, and like they can't figure out like what it looks like. But if you were to just connect the points, like, you know, when you were little and you would connect the points, you go left to right, you'll draw the correct graph. Okay? All right, I think I'm going to do one more and then call it a day. Which one's harder for you, the square root or the cube root? Cube. Okay, then let's do 8f. So this one is a challenge one. Here we go. What does this plus 1 mean? Up 1. Very good. That wasn't Tommy. That wasn't Tommy. So we went 0, and I went up 1, but we're going to wait first. Because this 1/2 is kind of going to mess with our pattern. The only time your pattern is somewhat messed with, and it's only going to be the y values it's ever messed with. It's not going to be the opposite. That 1/2 is doing what? Stretching or compressing? Good, compress. Now, I'm going to keep writing this pattern out so I know. But I'm going to write out my original. It was right 1, up 1, right 8, up 2. So that's my original. Now I'm going to talk about the transformation of it. Now, the 1/2 is only affecting the y's because that's the only thing that ever is affected. So my right 1 and my right 1 and my right 8 are going to remain the same. However, instead of going right 1 up 1, I'm going to go right 1 up how much? What's 1 times 1/2? 1/2. So up 0.5 or up 1/2. Instead of going up 2, what's 2 times 1/2? Careful. 1. Very good. Up 1. And I'm going to write this here. I multiplied by 1/2. 2 times 1/2 is really 2 divided by 2, which is 1. Again, please verify with your calculator. Make sure you're doing it right. Don't just like draw random stuff. If you get home and you're like, I forgot everything she said, get out your graphing calculator and just plot the points. That's easy. I don't really need to teach you how to use the calculator. You're fine now. But I'm going to teach you how to do it now without a calculator if you can. So here we go. I'm still at 0, 0, and now I'm going to go right 1 up like halfway. Right 8 up all the way up to the 1. And now we're into the opposite. I'm going to go left 1, down 1/2, left 8, down 1 full 1, and connect from left to right. There you go. See how it like compressed? It got smaller, shrunk a little bit. And I think that's it for today. Yeah. Tomorrow is a big day for you. Here's why. Because radicals are one of the biggest topics in Math 098. I think I talked about that already. So if that's your plan, next year is to take Math 098, then you need to really focus these next couple of days because radicals are just like expected to know how to do it. Hey. Okay, work on the homework. I'm going to circle the ones I want you to do.
Can we do evens?
I'm going to tell you which ones to do. Because some of them are harder than others.
My name is Tom.
Again, I give you little homework so that you can take your time. It does not mean that you shouldn't do it. Try your best. So this is going to be 11, day 3. 2.
My name is
Thank you.
Harry.
What?
What? I'm singing a song about Tony. Harry? There.
Yeah.
Yeah. It's just Harry. Right. Oh, that's Hey.
Oh, first page is fine.
No, it's still.
Okay. No, the whole first page is super easy and super fast. It's fine. But I only want to pick out one for the back.
In a box. Wait, what are we doing?
The whole first page,
Oh,
and then number 10. Well, like the only that one piece. So like 10 to 12. You're just crossing off this top part right here. This top part you can cross off just to give you some time. The back is review. The front is new. The back is review. This little top part right here you can cross out, but I want you to do just one of these. That's review to make sure that you're not forgetting what we're doing. I'm going to start doing that now because I feel like when we get to test, we're like, crap, I forgot to do that. But if you keep doing it every night, it'll be easier. The more practice, the better.
uh-oh.
The front page, you're just using patterns or you're typing them all in the calculator. That's the two options you have. They're really fast once you figured that out. Okay? It's only 7 questions. That's not hard. And you have 7 minutes, so look at that. Huh?
7 minutes.
7 minutes of fun.
7 minutes of
Bought Lysol now to make sure that all of you don't get me sick.
Oh, yeah.
Okay? You'll thank me later.
This is the serious floor. I don't know what it is.
Hey, this dude got the stomach flu, so don't blame me.
It's okay. Yes,
Us
three have.
It's in my mouth.
Us three have another.
Tommy has a stomach
Are you
flu
really?
now.
Yeah.
Tommy, it's okay.
I know. I'm gonna throw up. They say, well, you sprayed it in my mouth.
Because you're dirty.
It's all in the stomach flu, but here's something else.
Oh, I took it from you. Sorry. You're fine.
I think I got mono.
You're killing all the germs inside of
You
you.
said not to do number.
Just that one.
He said, I think I got mono. It's okay, you do it.
Can you at least get Febreze?
What's supposed to do with your
It's okay, Tommy. Don't think. You do.
Don't hurt his foot.
Oh, he's gonna go to the hospital again.
I got another bone.
Oh my god, you're the best. I didn't bring a lunch today. Thank you.
No way. Super sweet. They don't, I mean, they're good ones too. I saw it and I was like, okay.
Oh, you're the best. Thank you so much. I appreciate it.